Hello sir, I hope everything is good there. My name is Jai Chaturbhai Kakadia and my student ID is 2230044. Today I'm going to talk about my practical side of the uh, classification models I applied on two image dataset is called Fashion MNIST and CIFAR-10. So first step is to import the libraries. uh, this step is very crucial because without these libraries we cannot perform anything. So I imported pandas, numpy, tensorflow datasets to download the dataset, uh, sklearn, tensorflow. uh, in tensorflow I import the keras, seaborn. To visualization, I import the plotpy dot graph objects and matplot, and I import time to calculate the model running time. From sklearn, I imported these all libraries. Trend test split is using for splitting the data into training and testing set. Accuracy score for the calculate the accuracy score. Confusion matrix is for creating the confusion matrix. PCA is for uh, data pre-processing and dimensionality reduction. Then I applied grid search on every model. So I applied grid search CV from the sklearn model selection. Then here is our classifiers. The first classifier is logistic regression. In logistic regression, we applied multinomial class. So it will be multinomial logistic regression. Then I import the k nearest neighbors. Then I applied support vector machines and at last random forest classifier. So first of all, I'm talking about the Fashion MNIST dataset and their classification models. So first of all, I downloaded the dataset from the keras.datasets. Keras has so many datasets, and uh, by using Fashion MNIST.load dataset, I load the dataset from the keras library and store it into four variables, which is xtrain, ytrain, xtest, and ytest. To print the first 25 images, first of all I initialize the class names and store all the 10 class names in the variable class names. Then I printed down this is the code for the display the 25 images with labels. So first of all I initialize the size of the images, which is 10 by 10, and in for loop, uh, this is in for loop. I plotted images as the size of 5 by 5, and here is the training dataset, and the loop is running 25 times. So it will take first 25 datasets, and the label is a white train of 5. Uh, and we can see that 25 datasets uh, in 5 by 5 sizes. Second step is data pre-processing. Data pre-processing is very important for further model creation. So first of all I normalize the pixel values. For that I converted our pixel values in float and divided by 25, uh, 255. So our pixel values range is between 0 and 1. uh, to split the dataset, I create two more values X variable, X validation, and Y validation. uh, we perform to provide 10,000 validation data points and 5,000 train data points. We split the train labels, and then we pointed the shape of training validation and testing set. Here is the code for the normalized data to range 0 to 1 of the X validation and Y validation variables. And here we can see the shape of all the data, training data and validation data and testing data. For dimensionality reduction, I used PCA. uh, Here is the code of the reshape data from channel to row. So it will show the data in a row. then uh, then we perform the then we convert the continuous value uh, of the for the response variable to categorical value using the label encoder. Is the label encoder. For that, I have to apply the sklearn, and uh, from sklearn I have to import the pre-processing and utils packages. So y validation is not a continuous variable, so we have to convert it into categorical value. Then the main work is model creation. First of all, I apply multinomial logistic regression. So for that, because this code creates a warning, so avoid the warning, I import the warning, and here is the code for ignore that warnings, so it will look good. So here is the starting time, and here is the ending time, so we can calculate the model processing time. Then I store a logistic regression by using multi-class nomial with max iter 200 and random state 42. As I say before, I apply grid search at last. So before applying grid search, the parameter maximum iteration was 50. So after grid search, I change it to 200, and then I fit our training variables in a multinomial model and print out the uh, model running time, and it is 0.08 minute, so it's quite fast. Then for predicting the model, I initialize y train nomial, y predictor nomial, and pass the x test PCA value, and at last I printed out the training accuracy score and testing accuracy score, and after that I also printed the classification reports of our model. So as we can see, the 70% accuracy of training data set, and the 70.18% accuracy in testing data set. Here we can see the precision, recall, F1 score, and support of multinomial logistic regression model. And testing accuracy is very important. So it is 70. It's quite good. To visualize in a better way, we create the confusion matrix and plot it in a uh, and we plot it by using the heat map, and we can see all the actual values and predicted value of all classes. So it's quite good. Then I applied support vector machine. The process is same. Of the process is same in every models, but we only change the parameters and our model names. So I applied this model by using kernel RBF and gamma 0.1 and set the probability true. Then feed the data into a model and we calculate the time. SV support vector machine takes too much time. I don't know why, but it will take too much time in both the dataset, MNIST Fashion and CIFAR-10. Then I predicting the model and calculate the same trend accuracy, test accuracy, and classification report. The training accuracy is nearly 100%, which is quite good. And but the test accuracy is low. Test accuracy will become low, and it is nearly 90%. And we can see all the precision, recall, and F1 score and support values of support vector machine model. Then creating creating the confusion matrix, I used the cone matrix variable and pass the actual and predicted values by using y validation dot threaten, and the figure size is 9 by 6, and we can see the actual values and predicted values of the support vector machine classifier. The third model is random forest. uh, uh, we print the uh, random forest model classifier running time, and we use max depth and n estimator. Then we predicting the model, and the train accuracy is 1%, 100%, which is very good. But the test accuracy is 86 point nearly 87%, which is lower than support vector machine, because support vector machine has nearly 90% testing accuracy. And we can see the actual values and predicted values of the random forest classifier, and it is wrong here. It should be uh, class 2, but it predicted class 4. So we can see the actual and predicted values, and at last at last we applied k nearest neighbor classifier, and with matrix Minkowski, n neighbors 10 and weight distance. uh, Before I applied grid search CV on this classifier, it was a normal classifier. After that I passed these parameters to improve my model accuracy, and the training accuracy of KNN is 100%, and testing accuracy is 86.86%. And then we plotted our confusion matrix, and we can see actual and predicted values. Here is the comparison of all four classifiers: multinomial regression, support vector machine, random forest, and k nearest neighbors. And here is the table, and here is the uh, graph, bar graph, which is uh, easy to understand. As I say, I applied grid search at last. So here is the code of multinomial logistic regression grid search, and I pass these parameters for the cross validation. Because we have to use multinomial logistic regression. The multi-class is multinomial, and I only pass maximum meters. Here is the all the cross validation results, and it show the best parameters are maximum iteration 2000 sorry 200, and multi-class is multinomial. Then we apply grid search on support vector machine, and pass the parameters kernel linear and RBF, and the gamma is 0.1, 0.01, and 1.1. It will take too much time, and so I passed very few parameters. So, and it says that best parameters are 0.1 gamma and RBF kernel, but we can see all the cross validation between 0.1 gamma linear, 0.1 RBF, 0.01 linear, 0.01 with RBF, and so on. The third grid search I applied on a random forest classifier, and these are the parameters, which is n estimators and maximum depth, and the output is here, and the best parameter is maximum depth 250, and n estimators are 500. The fourth grid search is on k nearest neighbors, and we pass these three parameters, which is n neighbors. In n neighbors I pass 5, 10, 15, 20, 25, and 30, and the weights is uniform and distance. Matrix is Minkowski and Chebyshev. Sorry, my pronunciation is not good. And it will say that the best parameters are matrix Minkowski, n neighbors are 10, and weights distance. So it's 85, 85. And neighbors are 10, and distance here. So it is the best parameters for k nearest neighbors. Now we are going to see the classification methods on CIFAR-10 image dataset. The libraries will be the same. Uh, uh, then I load the database dataset from the Keras and store it into xtrain, ytrain, and xtest, ytest. To print out the 25 images with labels, first of all I uh, initialize the class names, and store all the 10 class names in the class name variable, and then plot it into iplot, and pass the labels here, class names. So this is the first 25 images of training dataset of CIFAR-10. The next step is pre-processing. First of all, we convert our pixels into float, and then divide it by 255, uh, it will normalize the pixel values in the range of 0 and 1. So then we squeeze the dataset and create two more variables, x validation and y validation, and we perform our models on basis of these two variables, and print out the all the dataset shape, which is training image shape is 49,000, validation image is 1,000, and test image is 10,000. Then we reshape the data uh, by using the dot shape. CIFAR-10 has a color data set, so it has one additional attributes, one additional dimension. For dimensionality reduction, I used PCA, and here is the code of dimensional reduction. Then for creating the models, first of all, first model is multinomial logistic regression uh, with maximum iter 125 and random state is 42, and the running time is 0.11 minutes. Predicting the model is the training accuracy is 40 and 39 for the multinomial regression. For the here we can see the actual values and the predicted values of multinomial logistic regression, and then we plotted the confusion matrix for easy to understand. The training accuracy of support vector machine is 94, and testing accuracy is 56, and in random forest the training accuracy is 56 and the testing accuracy is 43.5%, which is very low. uh, but we will discuss the reasons why it is low at last. And for KNN, the training accuracy is 100%, and the test accuracy is 38.3%, which is very low compared to the Fashion MNIST dataset. Then we compare all the accuracy and create the graph and grid search for the each classifier and get the best parameters. Uh, Now we are going to compare both the graphs and both the models. So as we can see, um, CIFAR-10 in CIFAR-10 the model accuracy is very low compared to the Fashion MNIST dataset. The possible reason of this is first of all, first reason is I think image complexity, because CIFAR-10 has colored images and Fashion MNIST dataset is grayscale image dataset. So it's quite difficult to recognize the images and training the model and predicting the values. The second reason is restricted data enhancement, because the training dataset is frequently made artificially larger through the use of data enhancement techniques, including image rotation, scaling, and flipping. The third reason maybe is overfitting. Overfitting occurs when a model learns the training data too well, including its noise and outlier. If the model is overfitting to the CIFAR-10 training set, it may perform poorly on unseen data, resulting in low accuracy. Uh, and I think uh, the fourth reason is adjusting hyperparameters. Uh, because it's possible that the model's hyperparameters like learning rate, bit size, and regularizations parameters are not tuned specifically for the CIFAR-10 dataset. Adjusting these hyperparameters can have a big effect on how well the model work. So here is the end of the explanation of my practical work on CIFAR-10 and Fashion MNIST image data series. Thank you for your time. Thank you so much.